All right, well, go ahead and get started here. We have an hour, so I want to make sure we're efficient with the time and get everybody out to their lunch hour on schedule. So I'm Liz Kuchke. I'm a research fellow at the Center for Sustainable Building Research. I've been full-time there for about 5 years now, working primarily on the B3 guidelines that we're here to talk about today. I have with me Rolf Jacobson, also from the center, to help with any issues that come up during the presentation and to help with our Q&A session at the end. So thanks, Rolf, for doing that. And
no problem.
Thank you. So getting into our agenda here, as soon as my computer responds. There we are. So we'll go through just a quick little housekeeping moment, some general updates to the B3 program, a lighting for energy performance crash course. I'll be talking about an update to our lighting and daylighting guidelines, specifically around the metrics for spatial daylight autonomy and daylight factor, and briefly touch on the small buildings approach. I'll talk through a bit of the process we went through in this update, and then I will demonstrate how to document compliance in using our B3 lighting worksheets and talk about some of the software available to complete the simulations we are asking for. And then I'll conclude with a case study from a recent B3 project, the Fergus Falls Public Library, which some of you may have seen before. The learning objectives, as stated in the announcement and for continuing education purposes, are to understand the importance of daylight in design for energy use, occupant satisfaction, and productivity, to understand how daylight design can be included in new construction and renovation projects, and to understand the different metrics that may be used to document compliance with the B3 guidelines, including for smaller buildings, and understand how to actually do the B3 compliance documentation and tracking. This webinar is being recorded. It will be posted on our YouTube page, and the link for both the video and the slides will be available on our B3 training and education page shown there on the screen. All attendees are muted throughout the duration, and we are asking that you use, please, the Q&A function in Zoom to ask any questions that come up. If there are questions that need to be answered immediately, we can do that. And then there will be time at the end to talk about more general things too. And lastly, there is closed captioning available for this presentation. The settings are in the Zoom controls. It's a little CC button that will allow for closed captioning on the broadcast. Oops. And in other B3 news, we have an upcoming training at the end of May here on a site and water update, including small and constrained sites, some updates there. And there's a link to register for that. And then in the beginning of June, we'll be running a second session of the whole building life cycle assessment for the B3 guidelines, which will be led by Rolf, who's on the chat here. It'll be 2 sessions, one of which is an introduction and an overview, and the second of which is a workshop. So you can register for just the introduction and overview or for both sessions, but to do the workshop, you need to have done the introduction. So the link for that will be available soon and come out in an email blast as this one did. And other general document kind of updates, the small buildings method is now available in the guidelines documents and on the website. And the small sites and daylighting update that we are discussing today and at the end of May will be available soon. The site and water updates are available for comment right now through May 6th. And let us know if you haven't gotten a chance to get those yet. It has gone out in the B3 email blast a couple times. So getting into our lighting design presentation here, we'll be doing a quick run through lighting design for energy performance. And these are the kind of basic steps that we'll talk about a little bit more in depth. First is to start with daylight. Second is to hit the recommended targets. Third is to reduce power, time, or both. Fourth, to utilize controls. Fifth, to utilize commissioning. And then sixth, to complete post-occupancy evaluations. So the first step to start with daylight, of course, is because daylight is free in terms of money and in terms of energy. It is abundant, and it is shown to have positive effects on human well-being. We have some rules of thumb for daylighting, and we know these aren't always possible, but we do want to maximize our opportunities in the pre-design stages of work. So things like orienting the primary axis to run east and west, usually utilizing narrow floor plates when available, high ceilings, open sections so that light can bounce deep into spaces, and then using high reflectance materials to redirect light that is captured. And here we have some just diagrams of general lighting approaches that demonstrate how light can be bounced using these various strategies. And then, of course, when you have abundant daylight, you also need to control it. So that's the second step. Because daylighting is different at all times, there are different strategies required to both control and utilize the daylight available. So to control glare and control solar heat gain, it is conventionally understood that it's easier to block the light outside the building than inside. And then control is also important, and these strategies can be tested in some modeling programs. We do have a requirement in the B3 guidelines to use glare control devices, and that requirement is not changing as part of this update. The next strategy is to hit the recommended targets, maintaining recommended light levels from the IES lighting handbook. For electric lighting, increase the lumens per watt that are being used with more efficient light sources, decrease the watts per square foot with the same way. Again, materials with high reflectance, and then strategic use of light to apply light where it was needed, where it's needed. And then to reduce energy, it is important to reduce power, time, or both. And that can be achieved with various efficiencies, things like lamp efficacy, the actual output of the electric light source, fixture or luminaire efficacy, which is how the fixture directs the light that is provided by the lamp source, the layout, how light fixtures and windows are placed to provide light, the room of the efficacy, again, the size, the interior materials and the reflectances, and then, of course, the task, making sure that tasks are located strategically to take advantage of available daylight, and then supplementing with electric light as needed. One important part of the energy and equation is controls. As we went over before, the light is different all the time. So control types are crucial to make sure that there's not energy being wasted when there's abundant daylight, and that when there's not daylight available, that light levels are maintained for productivity and comfort. So things like photo sensors, occupancy sensors, and time clocks can be very effective control strategies for a comprehensive lighting and energy strategy. Next is commissioning to ensure that the control systems and the lighting systems are operating as expected and perhaps being tuned as building use shifts over time, or as other changes happen to the users or the program. So commissioning and recommissioning can be a very valuable part of the lighting and energy scheme. And then finally, the use of post-occupancy evaluations. One moment. So post-occupancy evaluations are an opportunity for the people who actually use the building day in and day out to share their opinions and experiences on the systems that have been put in place to make sure they are operating as designed, and then that design intent matches the use, and provides also an opportunity for direct feedback, such as some of the text on the screen, like appreciating natural light coming in, or needing better control of that light. So the post-occupancy evaluation is a service that B3 offers that is required for some projects and an option for others. So more information about that you can email me for that if you are curious. So moving back to our guideline revision process here, that was the crash course. In general, we are constantly in a revision cycle of guidelines. We kind of move through the sections piece by piece, always trying to be up to date with the latest national standards and green rating systems as codes shift and as LEED becomes more advanced. We want to keep up with that. And then also we're also always looking to reduce administrative burden for project teams and improve performance. And both of those things were a focus of this little update section to the lighting and daylighting guideline. So the general intent of our guideline I5, which is part of indoor environmental quality, lighting and daylighting, is to promote occupant comfort by providing adequate levels of natural and artificial light to maintain sufficient light levels for the tasks being performed. Quality lighting can also support cognitive function, mental health, and social interaction while being aesthetically pleasing and complementing the design of the space. So the first measure in this guideline is about electric light levels, and there's no change in that from the previous version to this one. That guideline is to provide adequate light levels according to the IES guidelines and not including daylight contributions. The light levels are measured at the task plane, and also contrast ratios are maintained between the work surface and the wall and the work surface and the ceiling. And that is to ensure visual comfort for the users of the building. Next measure, I5B, is the lamp specifications. And again, no change to this part of the guideline. We are asking that light sources have a color rendering index of at least 80, unless necessary, special use case. And then that light sources should be RoHS compliant. And that is about the mercury content of lamps, which is fortunately becoming less of an issue as we move away from some of those older lighting technologies. So getting into the changes to the guidelines, they are in the I5C portion of I5, the daylighting. Excuse me for a moment. And so, as I mentioned, we are still maintaining the requirement for glare control devices on facades facing within 45 degrees of east, south, or west, either automatic with manual operation or automatic with manual override for 90% of all occupied spaces. And this again goes back to visual comfort, maintaining appropriate light levels, and the time shifting nature of light. So in the daylight utilization for our spaces, we are tweaking the definition of our spatial daylight autonomy guideline and requirement, and then we are reducing the requirement for daylight factor. So for spatial daylight autonomy, which for our purposes is defined, and for most green building standards, is a space, the amount of space that receives 30 foot candles of daylight for half of the occupied hours. And previously we had requested that the foot candle threshold be tied to the use of the space. So it was a little variable depending on the program in that space. And we have moved away from that complexity and moved to just the static 30 foot candles to move in line with programs like LEED and to reduce the effort that was required of project teams that we didn't see much of a benefit to on the other side, on the reporting side. And then the daylight factor change is quite a drop. It used to be a daylight factor of 2% in 70% of regularly occupied floor area. And we were getting feedback from teams that that threshold was not compatible with some of the other ones we were offering, such as the spatial daylight autonomy. And you may notice that there is no longer an option for point-in-time illuminance as a compliance method. We have decided to remove that pathway, and I'll talk a little bit about that later. Both of these metrics and the electric lighting requirement are based on a specific definition of a regularly occupied space for B3. So that is specifically a space that is occupied by one or more person for more than an hour during a day the building is in use. So that includes spaces that may be irregularly occupied, but when they're occupied, a person would spend more than a continual hour in the space. And excluded from those calculations are spaces that would require only minimal lighting, or the primary activity intended for the space would be harmed by daylight, things like movie theaters or dark processing rooms for various lab buildings or things like that would not be required. They would be excluded from the calculations. And then spaces that do not meet the minimum occupancy outlined above during daylight hours, or spaces where no individual person spends at least an hour during days the building is in use. And then the reporting and compliance portion of the guideline refers to the regularly occupied floor area. And that is simply the total floor area that is within the occupied spaces as defined above. So you will see both of those terms and they are related to each other. So I just wanted to show a quick example of what would be a regularly occupied space, and then how to determine that for this guideline reporting and simulation purposes. So when looking at a floor plan or a program list or a space list, it becomes obvious which ones, it can become obvious which are regularly occupied and not. And then there's, of course, some ambiguity. And we know that these spaces and room names and adjacencies will change throughout the project. So it is meant to be a kind of updated, the worksheet is meant to be updated as the project progresses and more information becomes available. So there, as I mentioned, there are clearly areas that are not going to meet that definition, things like corridors, electrical, mechanical rooms, storage spaces, things like that are not going to be included in this requirement for the guideline. And then there are spaces that obviously will be included, like offices, classrooms, things like that, that are kind of the primary function of the building. And in an effort to reduce the amount of simulations required and repetitious work, we are including some capability to group similar rooms that are similar in size and daylight condition to be called representative spaces. So for example, for the bank of offices sitting on the bottom edge of this drawing, those could be modeled as just one space, and then the results assumed across the rest of them to get compliance with our thresholds. And then there are spaces where there's some ambiguity on whether they're regularly occupied or not, things like a break room or a reception area. There may be somebody there for an hour or more. And so we just ask that the project teams clarify as best they can and make a informed decision on whether spaces will be considered regularly occupied or not. So part of the process of this guideline is to categorize and catalog these spaces that will be included in the guideline. requirements. So in this case, we would have private offices, open offices, a lunch break room, and then another set of offices that have a different lighting condition. So those would be considered differently in the spreadsheet and simulations. To finish out the discussion of the guideline, we still have our 2 recommended measures, which are not changed. Those are to use a color rendering index slightly higher to support human well-being and also visual comfort and display of things. And then again, for glare for visual comfort, for glare for electric lighting, to use direct only overhead lighting for 25% or less of the total connected load. So we're recommending, primarily indirect lighting for spaces there. And the last recommended guideline, also no changes, is the interior surface reflectances. I've mentioned these a couple times as a strategy. So these values for reflectances are just slightly above what is considered standard or best practice. So these are intended to just enhance and take full advantage of the daylight and electric lighting that is used within the project. So back to our metric discussion, just a little bit more in depth. As I mentioned, the spatial daylight autonomy is the percentage of floor area that receives at least 30-foot candles or 300 lux for at least 50% of the annual occupied hours. So this is an annual measure based on the occupancy of the building. And as I mentioned, we are changing our guideline language to specifically define the spatial daylight autonomy as that 30-foot candles for 50% of the occupied hours threshold, rather than having the foot candle threshold be variable based on the use of the space. So the B3 requirement is essentially the same with slightly less complicating factors to it. And that is for 50% of the regularly occupied floor area, which, as we recall, is the floor area within regularly occupied spaces. We're asking for 30-foot candles from daylight for half of the hours. So half the time, half the space, 30-foot candles. And then we have daylight factor. Which is the ratio of the light level inside of a structure to the light level outside of a structure. Daylight factor is a representative metric based on the CIE overcast sky for September 21st at 12 p.m. So it is a point in time measure, but it is representative of an annual metric. And the calculation is there. It's quite this formula there between indoor and outdoor luminance, and then it is reported often as a percentage of that. So the guideline has changed from a target of 2% down to 1%, and the area required to achieve that 1% reduced from 80% to 50%. Excuse me, I misspoke before when I said it was 70. So our new requirement is that daylight factor of at least 1% in at least 50% of the regularly occupied floor area occurring in regularly occupied spaces. And finally, the point in time illuminance would be the illuminance falling on the work plane based on the simulation measured at 9 a.m. and 3 p.m. on the equinox. And as I mentioned, and as you've seen, we are no longer using this as a compliance metric. We found the complexity to be not helpful for project teams or for us as reviewers of submissions. It requires more simulations than the other measures, and it seems to have fallen a bit out of favor in the modeling softwares as well. And then finally, we have our small buildings method, which is for projects that are under 20,000 gross square feet of conditioned space. And that definition is very specific and nuanced, and there's more information available about that in a previous small buildings method training and also on our website. So I encourage you to reference those if you are curious about the small buildings nuances. But so the goal was to reduce the amount of simulations and documentation that would be required for smaller buildings with smaller project teams. So we have moved to documenting or requiring simple window to wall area ratio or window to floor area ratios for these buildings and their regularly occupied spaces. And then a minimum visible transmittance for that window to ensure that the daylighting is maximized through our controlled window sizes. A quick look at what some of our peer guidelines standards are doing that you all may also work with. So the latest version of LEED, version 4.1, their daylight credit requires manual or automatic glare control devices in all regularly occupied spaces. So we're very close in line with that. And then offers 3 paths for daylight utilization. The spatial daylight autonomy, which matches our definition now. And they include the annual sunlight exposure measure. And as we know, LEED is point-based. So our threshold is right between their 1 and 2 points. So a project meeting B3 would receive the 1 point there, possibly 2 points. And then LEED still does allow for the illuminance simulation. It's very similar to what we used to. And then they also offer a post-construction measurement, which we do not allow. So, and then Green Globe's newest version from 2021, they require a minimum daylight factor of 2 in 50% of the regularly occupied floor area, and offer more points for more area or higher daylight factors. So our new threshold is lower than this because of the findings from our assessment process, which I will be talking about next. And I think it's possible that that we will move towards something like this in the future, but for now we are sticking with the 1 in 50% of regularly occupied floor area. I'm not seeing any questions yet, but please feel free to drop them if they come up.
Liz, we do have one question in the chat about furniture with reflectance ratings.
Okay.
I don't know if you wanted to cover that later or take a moment now.
Yeah, so that's a great question. Reflectance information in general is hard to track down, I found. I will say in the reflectance worksheet, which I'm not going to show today because it is a recommended guideline and we have kind of limited time at the moment, or limited time to present. It is available. I can send it to you, Erin. But that reflectance worksheet does include a list of reflectances from common materials that have been kind of cobbled together from various sources. So I can certainly pull that up if we have time at the end. And then I guess I would direct back to those sources where I cobbled the information together. And then manufacturers, I think, are the main resource for that information if they have it available. I've seen it on cut sheets certainly for surface materials, but for things like furniture with fabrics, it can be very hard to track down. So I don't have a great answer, but thank you.
And then could I just back you up a couple of slides to the LEED comparison slide?
Yes, absolutely.
I just noticed that it was the SDA was listed with 300, and I'm thinking maybe that was lux.
It's lux,
rather than
yes.
foot candles. Okay.
Yes, 300 lux, 30-foot candles.
Okay.
Yeah, And I will say I commonly see it represented as both. So a good rule of thumb is that 10-1 for Lux and foot candles. Sorry, I was just seeing Becky's comment in the chat that furniture values are requested for work surfaces and movable partitions. So there may be some more information on those kinds of things than other furnishings. Excuse me. I brought a cold home from Chicago 2 weeks ago and I'm still getting over it. So I've been talking about this threshold adjustment that we have gone through and is being presented today. So that was initiated based on feedback from our project teams and spearheaded and started by our partners at LHB, including Becky, who's on the call today. Between looking at what had been submitted from recent projects and then, coming through emails of questions and things, we came to understand that meeting the different thresholds that we had was requiring very different amounts of glazing and a lot of a very different effort level to achieve those. So we set the goal to bring our compliance thresholds in line with each other. And then also got feedback that the old or the existing spreadsheet tool was not clear and not helpful for documenting compliance and then submitting for the B3 guidelines. So we had the goal to simplify that tool and to streamline it, which I think we have achieved. So the study started out with box model comparisons of various glazing percentages, window to wall ratios in various configurations, and modeled in different softwares to see what kind of results we were getting and what the differences between those softwares would be based on internal rendering engines and settings and things like that. So we did a lot of tracking and comparing of results across spreadsheets and charts and tables to get kind of to where we are now. And then there was a sample building that was developed to do the refining of the spreadsheet tweaks and for this training session. So that sample building is this one. It is 7 rooms with various daylighting conditions. It has a 30% window to wall ratio on all faces, just a simple ribbon window for modeling purposes. So you can see there's 5 different lighting conditions, 6 different lighting conditions, and then a no window condition. So we wanted to test how the modeling softwares would return values for this, and then how our spreadsheets would track the results to display or to confirm that the project was compliant with our new or adjusted thresholds. So this is the result of the spatial daylight autonomy test. We used Sapphira for SketchUp, Lightstanza, which is a standalone web-based modeler that received the building from SketchUp, the model, and then Insight for Revit, which was the model was built to match the SketchUp one, but not exactly the same set of zeros and ones. And then tested it with a visible light transmittance of 0.42, which is the 0.42 numbers you see on the bottom there, which is the code minimum from ASHRAE 2013, 90.1 2013. And then with a visible light transmittance of 0.65, which is our required minimum for the small buildings method. So we wanted to just see kind of between those two glass types where these rooms would come in. And then set them all against each other to see how the different modelers stacked up for different metrics. So we see here, yeah, 6 runs of each of these different lighting conditions in our sample project, and a decent amount of variation between them. And we, went down rabbit holes trying to understand why there was this variation between modelers, and ultimately came down on that accepting them all as valid and knowing that there was just going to be some variation in the results. So we can see here that in some of the example, some of the rooms aren't quite meeting our threshold of 50 in some modelers. And so this is by design to see if then our area threshold still works, even if not all the rooms are receiving that amount of daylight. So office 3 and the conference room are the ones that are receiving less daylight right now, but because there's more daylight available than the others, it still should meet the guideline. And same story for daylight factor, same programs and visible light transmittances here. And again, we see the same kind of variation where, and interestingly, office 3 met the guideline with spatial daylight autonomy, but does not with daylight factor. So they're still not perfectly aligned, and projects may find that depending on the geometry and orientation of their room, that one metric is easier to hit than the other, and can use that to your advantage or not. So with about 18 minutes left here, we're going to get into the meeting the guidelines process eventually, which includes performing the simulations and then documenting the results. I'm not going to go over how to do the simulations in the various softwares. Those tutorials are available and will be linked, on our guideline website and stuff. So just in our interest of time and in leaving it up to the experts, I'm not going to be going over that, but each of these softwares we know will do the metrics we are asking for with the amount of specificity that we are asking for. Sapphira for SketchUp and Revit does both the spatial daylight autonomy and daylight factor. The daylight factor reporting is not as clear in Sapphira as it is in some other. It does require a bit of math. And again, we'll have some support documentation on that. And Sapphira also does not allow the user to change the surface reflectances. It works in these kind of industry standards, best practice measures. So rooms that have very different surface reflectances may not be modeled accurately in Sapphira. So that's just something to watch out for. And again, that could be to the project's advantage or disadvantage. Insight for Revit does both of the metrics, and the surface reflectances are set in the model itself, in the Revit model. So that's part of the modeling process there. Lightstanza, as I mentioned, is a web application that receives imports from Sapphira and Revit. And then the surface reflectances are set on the web application. And similar to Sapphira, the daylight factor reporting is less obvious on a room by room basis. It defaults to reporting the daylight factor of the entire building, which is not exactly what we need for our compliance metrics. So again, we'll have some support on how to get what we need out of Lightstanza. And then the Andrew Marsh tools are fully web-based. They can calculate spatial daylight autonomy if a weather file is provided, is uploaded to the tool, and then can do daylight factor as well. And again, the reflectance values are adjustable and are set in that web application. And I didn't get a chance to test the results in that Andrew Marsh tools against our other softwares, but I will be curious to. And then once the simulations are completed in these various softwares or in other ones that can achieve the same things, such as Elum tools or Climate Studio. And again, I didn't have a chance to get deep into those to dig up the specifics, but we believe they should be able to do at least one of the metrics that we're asking. The results are tracked in our worksheets, spreadsheets, as I've been mentioning, starting with listing the regularly occupied spaces that meet that definition from the beginning. And then listing the electric lighting levels that are designed, and then recording the daylight simulation results, and then again, the surface reflectance tool, which is the recommended guideline. So just for a refresher, these are our, I'm gonna show how to enter things into the spreadsheet and how it calculates. So these are our demonstration rooms here. So anyone who perhaps used the previous version of the spreadsheet may remember that it was all one big I5 spreadsheet. So our new approach is to have split workbooks that would be able to be shared more easily to the person who would be doing the work and documenting the work. And they spreadsheets are not linked, so they require some copy and pasting of information. Starting with this regularly occupied spaces spreadsheet, as we can see on the screen here, right? So in this spreadsheet, the spaces would be listed by name or room number or whatever is appropriate. And then the space type, the program selected from a drop down here with many options. And then if the exact or a close use is not available, there are also general IES categories that can be used for light level recommendations and referenced in the tab here, IES reference categories, which describes the task or the program and then refers back to its category. All that to say, you select your space type, which will then be tied to the light level recommendations for electric lighting in the next spreadsheet, and then enter the area of that space. And then the spreadsheet will automatically calculate the total regularly occupied floor area shown here. And then also the percent of the regularly occupied floor area that each space makes up. So this information, once it's all entered into the spreadsheet, will be wholly copied, all of the yellow cells copied, and then pasted into the various spreadsheets for documenting compliance, including the electric lighting spreadsheet, which I'm bringing up. So I'm going to copy this stuff here out of this spreadsheet. And then in our electric lighting spreadsheet, which is I5A, we will be able to paste that information here. And then the spreadsheet will find and return the light levels for the IES recommendations. See here in this blue column. And then project member, team member who is doing these simulations will be able to record their simulated horizontal illuminance. And the spreadsheet will then confirm that it is either too low for the recommended light level in this instance of 20-foot candles and a 30-foot candle goal, or that it does meet that target. And we previously had an upper limit on the foot candles here, and we've gotten rid of that too. So just for ease of use. And then similarly, once the horizontal illuminance is entered, the target vertical and ceiling illuminance will be populated for those contrast ratios. And again, these cells will change colors if they are, bright or not.
Liz, we've got a question about how to answer or how to add spaces if you have more than 25 different spaces.
Okay, yes, great, thank you. I'm going to answer that live. So I don't have a great solution. You can insert rows or, contact us. I can make you a custom spreadsheet that has many more spaces to maintain all of the formulas and stuff. I guess these front pages of the spreadsheets are not locked. So depending on how Excel savvy people are, you can, manipulate them yourselves, or I can certainly help with that. I hope that is an adequate answer.
Also, I think we're going to be using some representative spaces too, right? So
exactly, yeah.
Not every individual office has to be.
Exactly. And I see now another question, where are the spreadsheets located? Right now, they are still not public. They're still being kind of finessed and fine-tuned. But at the end of the presentation here, I will have my email address up if anybody wants to preview them or get them early to mess around with, give us feedback, try and break it. I'm more than happy to accept any and all feedback on these tools. So I can send them out to anybody who requests. So I just want to keep moving here. Thank you, Rolf, for letting me know. So similar to the electric lighting spreadsheet, the daylighting one works very similarly in that you will be copy pasting these spaces into it. In this one, you can see the spaces are copied over. And then in the daylight spreadsheet, big file, the I5C, there are tabs for each option, whether you're doing the spatial daylight autonomy metric or the daylight factor metric or the small buildings method. So as the simulations are completed and results are entered in this tab, the spreadsheet will calculate compliance based on the resulting spatial daylight autonomy and the weighted area of that room. These rooms are all the same size, so they're weighted the same, but obviously in real projects they aren't. So the spreadsheet is designed to accommodate that weighting of area and automatically turn green when the green yes when it is achieved. So, and similar functionality in the daylight tab as percent of floor area over a daylight factor of 1 is entered. The spreadsheet will calculate that area and then indicate when compliance is met. And I just want to note again that we are not asking for simply the daylight factor results in each space. We are asking for the percentage of floor area with a daylight factor of 1.0 or higher. And the software tools mentioned before can all generate that information, but it does require just a little bit more specific attention to the numbers being entered. So, and then the small buildings method spreadsheet will work similarly. It does not quite yet because we are still fine tuning how we want to calculate and report that information, but it will do the automatic, area weighted check, and it will indicate compliance when it's met. It just isn't quite yet. All right, back to our presentation here. With the last couple minutes, I just wanted to touch on a recent Fergus Falls library renovation and expansion project, which really did a great job utilizing daylight throughout. It was designed by Bentz, Thompson, and Rytow Architects with Gosman and Moore as the engineer and energy modeler. It's just over 25,000 square feet on a 1-story space. It's been occupied since 2019, and it was a finalist for our Best of B3 Design and Best of SB 2030 awards in 2021. And as part of that award ceremony, the project team put together a video that I'm just going to show a clip of that really highlights the daylighting portions. And this, the whole video is on our, if you're curious about it. Just saw Becky's note that the video audio is not shared. I'm going to just pop on the captions real quick because I do not know how to fix that in the time available, unless anybody else does. All right, so sorry that the audio didn't work on that. I apologize. It again, the video is on our YouTube page, so you can view the full length of it and hear the part about the daylighting. And I also just wanted to highlight our case studies, the B3 case studies database, which has lots of great information from all sorts of B3 projects and their performance and metrics and design strategies used. And then have just a couple minutes for any lingering questions. And again, my email address is here. Please let me know if you want to kick the tires on the spreadsheets. Happy to get feedback on those. And also if there's feedback on the guideline thresholds and stuff, we're always happy to have that. So thanks everyone for your time and your attention. It's been a wonderful process to get back into some daylight modeling and do some spreadsheet work again.
Thanks, Liz. That was great.
And I'm just going to leave the screen up for a few minutes for anybody needing to chat or write down information. We will be sending out certificates of attendance that you can use for your reporting purposes, for your various licensures and certifications and things. I expect to see those in the next couple of days. And again, this content will be on our training and education. And I'll drop links in the chat here if anybody's still around. There's links for our training and education page, and then there's the Fergus Falls library virtual tour video also in the chat. All right, thanks everyone. Have a great rest of your day. Enjoy the sunshine.